Hey guys, Mrs. O'Donnell here. This week we are going to be working with solving quadratics by completing the square. So today we're just going to start looking at completing the square, and then later this week we'll talk about solving. Okay, so our goal for today is to investigate completing the square, and we'll talk a little bit about converting from standard to vertex form. Here is our agenda for the week. You'll notice there's a lot that we're doing in Delta Math, but it's really all about completing the square, okay? So it's a lot of the same kind of thing. There's some review activities in there for order of operations, some simple operations, finding perfect squares and square roots. All right, so first of all, just take a minute. You could even pause the video and see what you notice and wonder given the pictures, the square area models, and your equations. All right, so if you're just coming back to us or if you never pause the video, that's fine. But hopefully what you're noticing here is you're noticing that we've got these, and we can even go to our next slide. Right? We've got these perfect squares happening in our area models, right? Perfect square in the upper left, perfect square in the bottom right. And you've got that for all of your area models. And hopefully you might even be noticing, hey, if I take the square root of 25, I get 5. So 5 and 5, right? Or 10 split into half makes 5 and 5. And 5 squared gives us that 25, right? So hopefully you're starting to see kind of some patterns here, right? So 6 split in half gives us 3 and 3, and 3 squared makes 9, right? 18, negative 18 split in half is negative 9x and negative 9x, and this negative 9 makes this 81. Okay, so hopefully you're starting to see some patterns here. You may also have noticed that this middle row right here is all factored form, and the bottom row that we have is all in standard form. Okay. I have linked this in your agenda as well. It's a Geogebra applet. It's under Tuesday if you want to hop on and just kind of play with it. Again, do that see, notice, wonder, kind of write down some things that you see going on with that Geogebra applet. All right, so what we're talking about here today is completing the square. So we've got this example, this x squared plus 10x minus 1. And if we were to think about it in sort of that idea of the area model, we're really just going to operate with this x squared plus 10x. And we're going to kind of set that minus 1 off to the side for right now, right? So if I have x squared, if I'm working with my area model, right, and I want to have a perfect square trinomial. That's my goal. So I have x squared, and then I have this plus 10x. Well, I'm going to take that and I'm going to split it. So I have a 5x and a 5x, okay? And then I've still got this like minus 1, off to the side here, okay? And what I can do here is I see, hopefully at this point you guys see, right? We've got a perfect square, right? We have x squared plus 5, and x plus 5, right? 5 times x is 5x, x times 5 is 5x. And what that gives us right here is a 25. So we've actually changed our problem here. We've added 25. Well, we're not allowed to do that. The only number we're allowed to add or subtract is 0. So I have to get a little creative. Instead of just adding 25 here, I'm going to actually also subtract 25 out here. Okay? So I've both added and subtract that 25. Okay, so I've really just added 0 in a really fancy way. Okay, so what does that mean? Okay, so what that means is I've got the expression. Let me see here. I'll go back to my purple. I've got x plus 5 squared minus 26. Okay, so I have now taken this x squared plus 10x minus 1 and converted it into vertex form. Okay, these two expressions are equivalent expressions. X squared plus 10x minus 1 is an equivalent expression to x plus 5 squared minus 26. And if you don't believe me, we can check it by going back through and multiplying it out, right? X plus 5. Ooh, that color is bad. Huh, it's very hard to read that blue, isn't it? Let's try orange. Let's see here. We can multiply back through to check our work. X plus 5 squared minus 26, right? So let's see here. In order to multiply x plus 5 out, I have to expand it. X plus 5 times x plus 5 minus 26, right? I'm going to distribute, or you could grab your area model, right? X times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. And I still have my minus 26. And if I simplify that, 5x plus 5x is 10x plus 25 minus 26. Well, 25 minus 26, that gives me minus 1. And I got back where I started. Okay, so that's how you can sort of check your work. They are equivalent expressions. Okay, so let's take a deeper look at what's going on here, right? So here we have 2 equations and we have algebra tiles, right? And if we annotate our algebra tiles, right, we've got x squared, we've got 1, 2, 3, 4, 5, 6 x's, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 ones. Okay, so we can very easily see where the standard form came from, right? X squared plus 6x plus 14. That makes sense. But now let's take a look, and I'll switch colors here. Switch back to purple. Let's take a look and see if we can annotate the same image to come up with this x plus 3 squared plus 5, right? So let's see here. If I'm figuring out my, treating this like an area model, I've got x and I've got 3x, right? And so x plus 3, and then same thing, I've got x and then I've got 3 x's, right? And if I multiply them out, right, I'm kind of treating this like it's that area model, right? Hopefully you guys can kind of see how I'm making my box here. And then if I draw down this way and down this way, right? X times x makes x squared, x times 3 makes 3x, x times 3 makes 3x, and 3 times 3, well, that makes 9 right in there. And I have 1, 2, 3, 4, 5 left over, right? So I could write the factored form of this area model as this x plus 3 squared, and then add on that extra 5 on the end. Okay, so for example, when you are completing the square, you're looking for this number, this sort of magic number, that you're both adding and subtracting on to complete your square, right? So in this case, I would be doing x squared plus 6x plus some number minus that same number plus 29. And if it helps you to fill in those kind of blanks in there, certainly go ahead and do that, right? So my goal is that these first 3 digits here, x squared plus 6x plus whatever is going to go in that blank, will become a perfect square trinomial, right? So you could come off to the side and make your box Okay, see here, so I've got x squared. I know this diagonal is going to make 6x, and it's going to split exactly evenly. So that's 3x and 3x. Well, that means I've got x, 3, and 3, and then 3 times 3 is 9. So my magic number here, maybe I'll switch this to blue. This magic number here is this 9. So that's what's going to both be added and subtracted. Okay, and when I do that, now I've created a perfect square trinomial, this x squared plus 6x plus 9, which is x plus 3 quantity squared. And then outside of that parentheses, right, negative 9 plus 29, well, that makes 20. Okay, so now I have just completed the square. And I didn't change my problem at all because I added 9 and subtracted 9. So I really just added 0 in a really fancy way. Okay, because I just added 9 and subtracted 9. So I did not change my equation. All right. At this point, you may start to be noticing another pattern here. Whatever number you see in that B term, okay, you're taking half of it and then squaring it. And that's oftentimes referred to as like the magic number, right? It's not really magic. It very much fits in the pattern, but it's referred to commonly enough that I feel confident telling you that. So, for example, if I wanted to convert this, that magic number that I want to add, okay, is going to be 4 divided by 2 and then squared. So 4 divided by 2 is 2. 2 squared is 4, right? So I'm going to have, let's see here, that would make, I'm going to come right here. So it's x, how do I want to do that? X squared plus 4x. And then I'm going to change color for that magic number. I'm going to both add 4 and subtract 4. And then minus 5. And what that gives me is x plus 2 quantity squared minus 9. All right. I could go ahead and do the same thing. Let's see here. I'll switch colors. Let's try red. X squared minus 6x minus 1. I could take that negative 6. I'm going to divide by 2 and square it. So negative 6 divided by 2 is negative 3. And then when I square that, I'm going to get 9. So I have x squared minus 6x. Let's see here. Plus 9 minus 9, because I'm really just adding 0 in a really fancy way, and then minus 1. And remember, the first 3 numbers are that make that perfect square trinomial. That's what you're trying to make, so that you could factor it really easily as x minus 3 squared, and then negative 9 minus 1 is just minus 10. Okay, go ahead. Challenge yourself, pause the video, try out letter E, see if you can get it. And remember, you can always check your work by multiplying back through to see if you get back what you started with. All right, so for those of you just coming back, ready to check your work. Okay, so let's see here. Let's see, our B value is at negative 2, so I'm going to take negative 2 divided by 2 squared. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So I have x squared minus 2x. I'm going to add 1 and subtract 1. Plus 5, and I've got my perfect square trinomial, x plus 1 squared plus 4. And again, you can multiply back through to check your work. And that is the basics of complete